Good afternoon, students. Today we will discuss force vibration in lectures. In first lecture, we have discussed force vibration excitation due to external applied force F0 sine omega t. Here we will discuss the force vibration due to rotating unbalance. Let any unbalanced force m0 is rotating in the system. The centrifugal force due to this m0 is m0 omega square. Since E is the distance, omega is the angular velocity, so centrifugal force is m0 omega square at the omega t angular displacement. It has two coordinates. One is vertical component and other one is horizontal component. Vertical component is m0 omega square sine omega t, whereas horizontal component is m0 omega square cos omega t. The vertical forces acting on the systems are: due to spring force is kx, due to damper it is cx dot. So the equation of this system can be written as mx double dot plus cx dot plus kx is equals to m0 omega square sine theta, since vertical, it is the only vertical force acting in the system. So force polygon, as in excitation of as in external applied force F0 sine omega t, here is also we are using this force polygon method. The force polygon in which F0 is replaced by m0 omega square, kx minus m omega square is the same, c omega x is also the same. We will apply Pythagoras in this triangle and we will get x, the amplitude, m0 omega square divided by under the root k minus m omega square whole square plus c omega square whole square. Dividing by k, we will get m0 omega square by k. Similarly, we will divide this figure, omega k by m will become omega n square, so it will become omega by omega n ka square. So x divided by m0 omega, m0 divided by m is the total mass of the system, m0 is disturbing mass due to rotating unbalance. So the equation may be written as x by m0 by m is equals to omega by omega n ka square divided by 1 minus omega by omega n ka square total ka square plus 2 zeta omega by omega n ka square. And phi angle from this triangle we can found, that is tangent inverse 2 zeta omega by omega n divided by 1 minus omega by omega n ka square. So the amplitude is calculated from this equation. Similarly, sine phi angle also calculated. Response curve. The difference between earlier curve and this curve is it is starting from this 0. The earlier curve was started from 1. This is due to at low speed the centrifugal exciting force is small, and therefore all the response curve will start from 0. In case of resonance, when omega is equals to omega n, at this point we will put omega is equals to omega n equation, we will get this x by m0 by m is equals to 1 divided by 2 zeta. And when the system velocity is quite high than the natural, omega is quite omega by omega in greater than 1, large ratio, then means this 2, 3, 4, 5, then the ratio of this x by m0 e by m tends to 1. This all tending to 1. They are all reaching to this 1 as we are increasing the velocity ratio. These are tending to 1. Now the force vibration due to reciprocating unbalance. As in reciprocating system, let m0 is the reciprocating unbalanced mass, total mass is m, omega is the rotating speed of the crankshaft, L is the length of connecting rod, m is the total mass of the engine, similar that of the earlier derivation. As we know, the inertia force due to reciprocating unbalance is m0 e omega square sin omega t plus e by L sin 2 omega t. Primary unbalance force and secondary unbalance force. Since the length L connecting rod length is quite higher than the E radius, hence the rest E is, since L is quite higher than E, hence the secondary unbalance force can be neglected. So the exciting force will be as of the primary unbalance force, that is m0 e omega square sin omega t. Now it is the same as that of the earlier derivation of rotating unbalance. So the same derivation will be valid for reciprocating unbalancing system, and same curves, response curve will be valid for reciprocating unbalanced system. Now the force vibration due to excitation of support. Let this support is also moving with the displacement vector y, that is equals to y sin omega t. Let the support is excited by y sin omega t, y dot is y omega cos omega t, y double dot. So we are calculating it by two methods, absolute and relative method. First, by absolute method. For absolute method, we are writing the differential equation, that is mx double dot plus c relative velocity, that is x dot minus y dot plus k x minus y, that is equals to 0. It is similar as that of if there are dumps in the road, then the support will also move. कई रास्ते में खड्डा आ गया, स्पीड ब्रेकर आ गया, तो सपोर्ट भी अपना मूव हो रहा है, अप डाउन हो रहा है. तो y is also moving, support is moving with sin omega t, y sin omega t. So it is relative velocity, it is relative displacement. The equation can be written as mx double dot plus cx dot plus kx is equals to y ky plus cy dot. Now we are putting the value of y and y dot. So this will equation y k sin omega t plus c omega sin omega t plus 90. The force polygon for this spring spring force and this damping force can be drawn as this ky perpendicular, this is cy omega, and this is the resultant. The resultant is square of these two terms, that is ky square or cy omega chi square. So the resultant, it is at the angle of alpha, omega t forward. So the resultant of this equation first can be written as y underscore k square plus c omega k square sine of omega t plus alpha. So the equation 1 will be mx double dot plus cx dot plus ky is equals to y under the root k square plus c omega square sin omega t plus alpha. Let the solution for this equation is x equals to x sin omega t plus alpha minus phi. Now it is similar at that of earlier derivations, in which f0 is replacing here by y under root k square plus c omega ka square. A similar force polygon can be drawn for this equation by replacing the value of x dot and x double dot. We will get x is equals to y under root k square plus c omega ka square divided by k minus m omega ka square plus c omega ka square ka under root. Now we will get x by y is equals to under the root 1 plus 2 zeta omega by omega n ka square divided by 1 minus omega by omega n ka square total ka square plus 2 zeta omega by omega n ka square. This term x by y is known as motion transmissibility or displacement transmissibility. Similarly, phi angle and alpha angle can be find out as on a slide. Now the second method is relative amplitude method. Let z is the relative displacement of mass with respect to support. We are putting displacement x minus y is equals to z. So the x is y plus z. So the equation mx double dot plus cx minus y double dot plus c can be written as, we are replacing x dot by y dot plus z dot, x minus y we are relative displacement velocity, z dot relative displacement is z. So the equation may be written as mz double dot plus cz dot plus kz is equals to minus m y double dot. Therefore, now we are putting value of y dot and y double dot, as y double dot is minus y omega square sin omega t. We are replacing it, putting it here. So the equation 1 can be rewritten as mz double dot plus cz dot plus kz is equals to my omega square sin omega t. So the here also f0 is replacing by my omega square. So the z by y can be written as omega by omega n ka square divided by same factor 1 minus omega by omega n ka square plus 2 zeta omega by omega n ka square and phi. So the graph for this z by y response x, it will be same as that of the x by x xt, as we have as same as that of we have discussed in first derivation of excitation by due to external applied force in lecture 1. Same magnification factor are valid for this z by y and same phi angle as that of earlier derivation. Thank you.